Hi everyone, welcome to my channel, Tutorlini Test Prep. Today we'll be going over lesson number 20 on how to use Desmos for the digital SAT math. Typing shortcuts and UI. Let's get started. Part 1, Navigation. There are shortcuts for zooming in and zooming out, however you can just pinch on your trackpad or touchscreen, but guys, please just buy a wired USB mouse. They can cost as little as $5 and will make your life a heck of a lot easier. If your device doesn't have a USB port, but it does support Bluetooth, you can consider buying a wireless Bluetooth mouse. Here's one that I recommend. Costs a little bit more, but still way less than the exam fee. On a computer mouse, you can use the scroll wheel to quickly zoom in and zoom out within Desmos, and you can use the left mouse button to interact or pan/move your graph window around. This is way more precise than doing it on a laptop trackpad, and it'll increase your speed and efficiency. Okay, so let's say I want to find the solution or solutions to this system. I'm going to quickly, I don't see any graph, right? So I'm going to quickly zoom out by going down on the scroll wheel. I'm going to pan to where the graphs are. I'm going to zoom back in by going up on the scroll wheel. And then I'll click with the left mouse button to quickly see that the solutions are 30,10 and 31,11. Part 2, Clear your graph. So if you didn't know, the Bluebook app, when you go from question to question, stores your work from the previous question, which you often don't want. What most people do to get rid of it, what a lot of people do is, they'll just start clicking on these X's to get rid of these expressions, and that's helpful for, if you mess up on some of your work. But if you go to do that, the colors are going to kind of get lost along the way. You want to clear the whole graph so that everything gets reset, including the colors. So here's what you should really do. So to clear our graph, we're going to click on the gear icon in the top right corner of the scratch pad. And then we're going to click on Delete All. Desmos tells me graph cleared. And sure enough, if I go and start typing stuff in, the colors are how they should be. I would do this at the beginning of each question, as long as you're sure you're done with the previous one. Part 3, Restore your window. Okay, so let's say for whatever reason, I was incredibly zoomed out. Maybe I was on the previous question. I forgot to clear the graph, but I already typed some stuff in. I don't want to clear the graph again because I'm gonna have to type all that stuff in again. But I want to get this nicer window back, the default window. So there's a shortcut for it, but probably the easiest thing to do is to just click this little home button that pops up on the right. It says default viewport. If you click back, that'll put you back to your kind of default window, kind of around -10 to 10. Part 4, Adjust your window. Okay, so let's say I'm doing a word problem where getting a really clear picture of the graph is really important. So for example, this projectile quadratic function I have plotted and I can't see anything. So the first thing I'm going to do is just zoom out a ton using the scroll wheel. And you see, even when I zoom out, this still looks like garbage and I can't really tell what's going on. So I'm going to click really quickly and just kind of gauge, what are the X values going to? And then maybe I'll add like a couple to each side. So how about I do like from -2 to like 18, and I'm going to click on the wrench and I'm going to make the X bounds -2 tab 18, and then the Y bounds, it's going from 0 up to 1200. So I don't know, why don't we do that like -100 to 1300. And then if you really want to make sure that you don't accidentally change the bounds by panning with the left mouse button, you can click this button here, Lock Viewport. There's way more options in here, but you don't have that much time to make a perfect, beautiful graph in like a 30-second to a 2-minute SAT question. But you see, this is still way better than what we started with. And I can now very quickly tell the initial height, the time it takes to reach the max height, and the time it takes to hit the ground. Part 5, expressions list plus Bluebook app. So a couple more random tidbits about the expression list. If you press enter, you will automatically go to a new expression. You can use the arrow keys to navigate between the expressions, though it might be easier to just click with the mouse. If you're doing, let's say, you're doing some numerical calculations that are really long, like let's say you're doing a mean calculation or something, you may want to change the size of the expression list. So if you hold your mouse right over to the edge, the right side of this white kind of scratch pad area where the expression list goes, we can drag this to make this much bigger so that because we don't really care about the graph. And similarly, I think you can actually drag it and make it a little bit smaller as well. Let's say you already typed your graphs in and you wanted to get a clearer picture of the graphs. You don't really care about what's typed in. Although often I find the vast majority of the time the default kind of width is perfect. Also, let's say you have some graphs and you, for whatever reason, want to completely hide the expression list. You can hit this button in the top right corner, hide expression list, and it will hide it. And let's say you want to bring it back out, you can click on show list. Okay, for the Bluebook app, everything that we've been doing in the Desmos browser still applies. Don't forget that the calculator is in the top right hand corner up here. And little tidbit that's kind of exclusive to the Bluebook app, if you're using a laptop like I am, that if you want to make it look more like the browser, you're going to have to click this button here at the cost of it maybe potentially covering up the question. So you might want to write some stuff down on your scratch paper, then expand the window. And then you can also click this black bar at the top to kind of drag it around, maybe if you want to put it more in the center of the screen. And everything else we were still talking about still applies, right? I could hide this, I could drag this, make it bigger or smaller, all that good stuff. Then when I'm going to put Desmos away, I click this X. Then one more time, guys, don't forget when you pull up the calculator, your work from the previous question is going to be stored there. You can't refresh this because it's not a web browser. So remember to click this gear and hit delete all to clear your graph. Okay, guys, one thing I neglected to mention was the undo button. I never really used this, but you might find it helpful. So let's say, I don't know, this is probably the most helpful use I can think of it. Let's say I go to like extend my window and I accidentally like click on this X here. And I obviously didn't want to get rid of that. So if you click this undo arrow, you can change it back. And if I click this redo arrow, you can redo whatever you did, but probably only the undo arrow will be that helpful. You're never really typing that much stuff in anyway, so it's not that much of a deal breaker. But if you do accidentally get rid of something, it is good to quickly get that line right back. Part 6, parentheses plus operations. All right, so to do addition, you just press Shift and then the plus key on your keyboard. To do subtraction, that's just the hyphen. And then to do multiplication, that is just Shift and then 8. So the asterisk. We'll give you a multiplication dot. Worth mentioning, lots of other calculators, they require you to use different buttons for a minus sign and a negative number. Desmos doesn't require that. So you see if I do 8 minus negative 2, it automatically makes it a plus sign and gives me 10. To do parentheses, you just do Shift 9 and Shift 0 on your keyboard. Let's do an example like that. You guys will notice that there is this kind of keypad and functions menu that has a lot of these features in them, but I hope you realize that using the shortcuts that I will teach you now and for the rest of the video will save you a lot of time. Part 7, fractions plus the fraction button. Okay, so let's say I did a bunch of work and I got a fraction as an answer and I want to see if it simplifies. So I can type in 24 and then slash 36 and I can press tab to exit that entry, that part of the fraction. And then if I come over here and click on this fraction button, it will tell me that it is 2/3 simplified. I can do the same thing with the decimal. So if I type in 0.35 and then click on the fraction button, it tells me that is 7/20. I can also do operations with fractions. So let's say I want to do 3/4, so 3/4, and then I'm going to press tab to exit that denominator, plus 8/5, tab to exit that, and I'm going to once again click the fraction button to see that that's 47/20. Little confusing, guys. There is no division key. So if you want to divide something, especially a fraction, it can get confusing really quickly. So let's say I'm going to do a complex fraction, a fraction divided by a fraction. I'm going to press slash first, and then I'm going to do another fraction. So I'll press the fraction button again. So let's say I want to do 2/7 divided by 4/9. So 2 tab 7 tab tab, and now I'm on the bottom. I'm going to do another fraction, 4/9, and I see 2/7 divided by 4/9 is 9/14. Now let's say I want to do f of x equals x squared plus 5 over x minus 3. If I type in the x squared plus 5 and then do a slash, it's just going to put the fraction on the 5. That's because the numerator is more than one term. So you have two options. You can, once you've typed that in, realize, oh man, this isn't working. You can highlight it, the numerator, and then press slash, and it'll put a fraction underneath the whole thing. Or what you can do is you can just recognize that you have a more than one term numerator from the beginning and just press slash at the very beginning, kind of like I was doing before. That makes your life a lot easier. So x squared plus 5 over x minus 3. Might be a good habit to get into just in general, to press the fraction button before you start typing the slash. Lastly, if you ever solve a problem using regression, you should know that if one of the parameters is a fraction, that fractional value gets stored. So you see I regressed this line and the slope, I'm like, what is that, 0.714286? And if I press M and then hit the fraction button, it tells me it's 5/7. And now before moving back to look at the answer choices, I'm going to translate those parameters, now that I know exactly what they are, and make sure that that equation fully replaces my regression. Very helpful. Part 8, exponents. So to type an exponent, we're going to do the caret key on the keyboard, which is shift and then 6. So let's say I want to do 5 to the power of 2. So I'm going to do 5 and then shift 6. Hold down shift and press 6, the caret key. Put 2. And then to exit that field, I'm going to press tab once again. And I see that 5 squared is 25. You can do lots of computations like this. So let's say 2 squared tab times 3 to the 4th tab. Make sure that if you're substituting or something, you may need to use parentheses when you're typing in your exponent. And last and certainly not least, we kind of run into the same issue as fractions when we have an exponent with more than one term. So let's talk about that. Let's say I have f of x and I want to do 5 to the quantity x plus 3. So you see if I type in x plus 3, it automatically puts the plus 3 outside of the field we were in, which is very annoying, and it's rather inconsistent with how the rest of the software works. So there's a couple of things you can do. Probably, maybe most easily, is you can type in a parenthesis first, and then it'll kind of force it to stay up there. And then you could even retroactively remove the parentheses, and it would look like how you want, 5 to the quantity x plus 3. You can also kind of do what we were doing with the fractions. Like, let's say you could just type it all out and then just highlight the x plus 3 part and press Shift 6 to raise it into the exponent. Very tricky. Make sure you know how to do that, because they love asking about functions like that, and a lot of times graphing them makes them a lot easier. Lastly, everything we learned about fractions still applies. So if you wanted to, if you had to, for whatever reason, put like a fraction in the exponent, you could do that. For example, a very common one is a fractional exponent. So just, let's say 2/3. I didn't even need to put parentheses or anything. It just let me keep that fraction in there, which was really convenient. Part 9, absolute value. So absolute value is very easy to type in on your keyboard. We don't need the function menu. What we're going to do is we're going to press the vertical bar key on your keyboard. You just hold down Shift, and then you press the vertical bar, which is the button directly above Enter. And then I could do, let's say, absolute value of -8 tells me 8. Absolute value of 0 tells me 0. And I could do absolute value of 5 plus absolute value 8 minus 17. And it tells me 14. Now, you don't really see absolute value computations that much on the SAT anymore. However, you're going to see this a lot when you go to solve absolute value equations or graph absolute values. So make sure you know how to do that. So for example, f of x equals absolute value of x plus 2. Again, I'm pressing vertical bar whenever I need to do an absolute value bar, minus 6. So making these graphs could be really helpful if you needed to solve an absolute value equation, which I already covered earlier in the playlist, but why don't we do one really quick? Okay, again, already covered this in both my equation solving videos, but you see I typed in a big messy absolute value equation and I can't click on it. That is mighty unfortunate. So I'm going to graph y equals the left-hand side of the equation, 3 absolute value, so vertical bar on the keyboard, 4 minus x plus 2. Absolute value 4 minus x. And then y equals the right-hand side, so 19. And we get the solutions are 0.2 and 7.8. Part 10, pi. Okay, guys, this is a bit of a moot point because almost always on the SAT, they want you to get the exact answer for circumference and area and stuff like that in terms of pi, in which case it would be better to just kind of do it either by hand or maybe using a scientific calculator that can work with pi. Now, that being said, let's say you do need to use pi to make a graph or to compute a approximated area for like a multiple choice question or something, or maybe a question says to round. So to type pi anywhere on Desmos, you don't need the functions menu. Just press lowercase p followed by lowercase I. So you see pi is 3.14159. Looks good. So let's say, I don't know, the radius of a circle is 5. I don't need this graph here. And I want to find the circumference. So circumference is 2 pi r. Area equals pi r. And then I press Shift 6 to do an exponent squared. And let's say I wanted to do 2 pi over 3 radians and convert it to degrees. So I'm going to do 2 pi over 3 and then multiply by 180 over pi, and I see that gives me 120 degrees. Part 11, radicals. Okay, so to do a square root, we're just going to type in SQRT, all lowercase. So let's say I want to do square root of 25, SQRT. I would type in 25. Just like everything we've been doing, guys, just press tab to go on to the next field if you need to keep typing. If you need to keep typing inside the radical, keep typing. But if you want to exit that radical, make sure you press tab. I could also do, for example, SQRT square root of 81. And I'm going to do that all under the same radical, so over 16. And I see that that's 9 over 4. If we want to do a cube root, we could do CBRT of, say, 27. Same deal, press tab to exit the radical. And if you want to do a different root, which is almost kind of irrelevant, square roots and cube roots show up a lot. You could do, if you want to change the index, you could do nth root. So NTHROO, and when I press T, it'll give me kind of a blank radical. So let's say I want to do the fourth root of 16 cubed. So I'd press 4, tab to go to the next field, 16, shift 6, cubed, tab, and I get 8. However, was that really worth it? It's kind of a really important concept that you know how to change that to a fractional exponent. So I don't know, the last one might not be that helpful, but I would definitely make sure you know how to type in square roots and cube roots because they show up all the time. Part 12, inequalities. So once again, guys, we do not need the function keypad because the less than and greater than buttons are directly on the keyboard right next to your question mark and your M key. So I'm going to do, let's say x is less than 3, x shift and then comma 3. And then let's say I'm going to do y is greater than 2. So y shift period 2. What lots of people don't realize is that you can type in less than followed by equal and then greater than followed by equal to do less than or equal to and greater than or equal to respectively. So let's say I do y less than equal, Desmos automatically changes it to a less than or equal to sign, 2x plus 3. And let's say I do y is greater than or equal to 5x minus 4. Part 13, lists and statistics. So some of this I already covered in my mean and median video. What lots of people do is they'll just type in, say, mean, and then they'll type in their list. However, this can take a really long time, a lot of typing, if you need to alter the list throughout the problem, or maybe do multiple calculations. Remember, guys, in the Bluebook app, you cannot copy-paste stuff from one box to another like you can in your web browser. So what I'm going to do is I'm going to pull up a data set, and I'm going to make a list in Desmos. I'll call it, say, capital A. We use a square bracket separated by commas to make a list. So I'm going to do 3, 12, 1, 4, 15, 6, 10. Now I can very quickly find the mean, the median, using the mean and median functions without typing them out multiple times. I can even find the range by doing max of A minus min of A. And there's another function that you might find helpful once in a blue moon called stats, which just kind of conveniently lists for you the min, max, and the median, which the SAT tends to ask about a lot. Notice how convenient this is if I have to add a number or add a letter or a constant or something. I can just add it to the list, and then everything will automatically get updated. Part 14, tables. So if we want to make a table, what we're going to do is we're going to click on this plus in the top left of the expression list, and then click on table. You can navigate through the table using the arrow keys. However, if the SAT gives you a table full of points, you'll probably find it easiest to type them in kind of like you're reading a book left to right, and using the tab key to go from the first entry to the second entry, and so on and so on. So watch what I do. I'm going to do 0, 9. So 0, tab 9. Now I'm going to go to the next point. Tab 1, tab 6, tab 2, tab 5, tab 3, tab 6, tab 4, tab 9. Again, went through that kind of slow for the demonstration, but it's probably much easier than clicking each time over and over again. So just like in the previous parts of the video, the tab key is your best friend. So let's say an SAT question tells you that this right function isn't y, it's actually f of x. So we could call that f1. And let's say we have a new function, g1, which is all the f1s but subtracted by 4. Well, all of these columns in the table, guys, are stored as lists, and we could do computations on them. So let's say I want to do g1 equals f1 minus 4. Let's say I want to shift it 4 down. And then I'm like, what does that look like? Well, I could type in parentheses x1 comma g1. And why don't I change the color just to make that look a little nicer? Oh, that certainly looks like it went 4 down. Why don't I get rid of this first guy up here? And this is a quadratic, so I'm going to regress this as a quadratic in standard form. But instead of using f1 or y1, I'm going to use g1. So g1 tilde ax1 squared tab plus bx1 plus c. And I get a really nice regression. So not only can you call on lists from the columns within the table, you can use the columns of the table to call on functions. So let's say I have this function f of x equals x cubed, and I want to see some points plotted on that really quickly without kind of typing them all in. So I'm going to make a table, and I'll do, how about -2, down arrow 0, down arrow, or sorry, -1, down arrow 0, down arrow 1, down arrow 2. And I'm going to come over here, instead of f1, instead of y1 or f1, I'm going to type in, because I have that function f of x defined, I'm going to type in f of x1. And you can see it very quickly fills in all 5 of those y values for me without me having to compute them. That might be helpful for a question here and there. Part 15. Geometry functions. Okay, so as I went over in my equation of a circle video, the distance and midpoint functions are incredibly helpful if you need to find the center and the radius of an equation of a circle that's not in that nice, if it's in kind of the standard form, not in that kind of nice general form, x minus a squared plus y minus k squared. So you see this one's like expanded. I don't know, I can't tell what the center and the radius is just by looking at that. So what I'm going to do is I'm going to think about it like a compass and click on the north and the south. So north is -2, 13. So let's do n equals -2, 13. And I'm going to label that as north. South is -2, -1. I'm going to label that as south. And now I'm going to use the distance function, which will tell me the diameter, the distance between those 2 diameter endpoints. And then I'm going to divide by 2 to get the radius. So the radius is 7. And now I'm going to use the midpoint function, again using parentheses and commas, to find the midpoint. And if I click label, it will tell me that the center of the circle is -2, 6. Okay, the context for this question is from my linear test 5 unique video. It's a problem from the College Board. They give us the center of the circle, and T is the point of tangency. So it would be really nice to start making this picture if I could quickly figure out what the radius is. Well, I can use the distance function, and I don't need to divide by 2 because from the center to any point on the circle is the radius. So I'm going to do distance from C to T. And that tells me the radius. Now, it's a little like, what the heck is that? Well, If I square it, it'll tell me the radius squared, and that's really all we care about when we make the equation of a circle anyway. So the radius squared is 61. Okay, guys, so I kind of typed in the equation of the circle using what we just learned and my knowledge of what the equation of the circle is. X minus h squared plus y minus k squared equals r squared. If you want to see more of this problem, go check out my video on linear test 5 unique. It's like the very last question in the video. So what I wanted to show you here is why I find the polygon function useful, because the digital SAT has been asking a lot about these like tangent line of a circle questions. So you see I drew the tangent line. I just did that off screen. But I don't need to come up with the equation for the radius to add it to my drawing. I can use the polygon function, which will make a polygon from any set of points. Now, is it really practical to draw like a triangle or a trapezoid or something on the SAT? No, that's not really that helpful. But this polygon function is really good for drawing line segments. So if I do from point C to point T, it'll make a radius, and I can use visual inspection to see, oh, it approximately looks perpendicular, so I probably did a good job. So that's probably the only case where I would use the polygon function. I still think it's helpful. Part 16, trigonometry. Okay, guys, so once in a blue moon, you do get a unit circle trig question that is straight up just the sine, cosine, and tangent of something in radians. So notice if you click on the gear over here off to the right, you will notice that the default unit is in radians. That is good. Pretty much anytime you would want to use sine, cosine, and tangent, you'd probably want it to be in radians anyway. But if you do want to change it to degrees, you got to remember to do that because the default unit is going to be radians. Okay, so let's do cosine 2 pi over 3, 2pi/3, tab parenthesis, sine pi over 2, and tangent 7 pi over 4 radians. Now you guys will notice that all came out really nicely. I cherry picked good ones. I highly recommend, if you have the money, that you don't do this on Desmos. Memorizing the unit circle and how to draw all those triangles is kind of a lot for just a couple questions. You can get a scientific calculator. Many of them cost like $15 to $25. That will do unit circle trigonometry like this for you. Because as you see, if I go and type in, say, cosine of pi over 4, Desmos is not going to be able to tell you that that is square root of 2 over 2. But a scientific calculator with the capability to do it will be able to do that. I went over this in my Ottocento on sine and cosine properties. Really the only other thing I can think of that you might want to use these functions is like these equations where they give you in degrees and they expect you to recognize that they add up to 90. I talk about it in my Ottocento video. I think it's number 12. Just note that if you are going to do it just by typing it in, there's a better way to type it in that I go over in that video. But if you are going to type it in exactly like that, you're going to have to change it to degrees. And then go to the exact first solution. So this one would be 66 degrees. As you can see, guys, it's way better to just understand the concepts from that video and recognize that they add up to 90. Part 17, labels and colors. Okay, guys, so a lot of you have probably figured this out, but I've glossed over this in a lot of my previous videos. These like circles on the side are really important. You can like turn off graphs by single clicking and then turn them back on. This is really helpful for checking to see if two lines actually have like infinitely many solutions. So see how if I toggle the bottom color on and off, I go, oh, they coincide. They have the, they're in the exact same spot. They have infinitely many solutions. So, but if you click on it and then hold down left click, so I'm going to hold down left click for like a second, it'll pull up this menu. And there's a lot of stuff you can change that's really helpful, but probably the most helpful thing is that you can change the color. So look, if I want to make this line purple instead, I can make it purple. And then if I want to make this parabola green, I can make it green. Now, before we talk about points, there's one other thing you can do that you might find helpful. When you have a vertex, axis of symmetry, or an asymptote, what you can do is you can click on this second option for like a dashed line, and it'll kind of remind you that that's not actually the graph. That's just there as a guide to show you where the symmetry is. I find this very helpful. You see kind of a similar thing going on with this exponential function. I plotted not an axis of symmetry, but the horizontal asymptote. So it's really helpful to me conceptually, maybe not in the actual test, but while I'm practicing, definitely, if I change this to the first dashed options, that I can just remind myself that that's not actually part of the graph, that's an asymptote. Okay, let's go over the same thing, but for points now. So I highly recommend you give the points both while you're typing, and then when you label them, some kind of letter that reminds you of what it is. So you'll see me oftentimes use C for center or T for tangency. Maybe I'll use P for point, just for this example. So I'm going to plot 2, 3, and I'm going to label it as point P. Now that point's actually draggable, so if I wanted to, I could change the color, and there's other stuff you can do, but most important thing, you could change the color. And if you wanted to, you could turn the drag off so that you don't accidentally like click on it and move it. I don't know, that always kind of bothers me a little bit. Let's look at another one. Okay, so let's say I have the system of inequalities, and then I typed in the answer choices. Notice how I both typed them in as A, B, C, D, and then I labeled them. I clicked the little checkbox to say label, and then I typed in over like here, capital A, capital B, capital C, capital D, so that it actually pops up on the picture. We've gone over this in previous videos, guys, but you just see it makes a lot of problems so much easier. Now, one thing I am noticing, first of all, I forgot to turn the drag off for this one, so let me do that. And I forgot to turn the drag off for this one. But I'm also noticing that this color, the colors kind of like cycle through. So I'm on red, and I'm like kind of red. That's kind of hard to see. So why don't I make this a color that's not used? How about orange? Not that much better, but it's a little bit better. And I can see that the solution to this system is kind of that west pizza slice where the red and blue are meeting. And it's looking like this one is answer choice C. Labeling the points just makes it so much easier to follow what's going on in the problem. Part 18, number functions. Okay, so a lot of these number functions really aren't that helpful on the SAT, but there's just two that I wanted to briefly mention. So one, if you want to find the greatest common factor of two numbers, you can use the GCD function. So GCD, greatest common divisor of, let's say, 16 and 20. And I see that the greatest common factor is 4. That's not really that helpful, though, because you don't really need to figure out greatest common factors to like simplify a fraction, because you could just use the fraction button, which we talked about earlier, right? For example, like 16 divided by 20, I can just click on the fraction button. I didn't even really need to figure out that they were both divisible by 4. What's probably more helpful is the LCM function, least common multiple. So if I want to find the least common multiple of 2 or more numbers, I just type in LCM. And let's say I do 4, 6, and 8. So the least common multiple of those 3 numbers is 24. This is really helpful when you need to clear a numerical denominator. Let me show you an example. Okay, so I go over this in a lot of my videos, but especially in my Ottocento number 6 on linear systems. And in the problem set videos, and even in some of the Bluebook app tests, you guys notice they ask you questions where they give you these like numerical denominators for like an equation of a line, and like the first step I talk about is like you need to clear the denominator, and then put it in standard form, and then use the proportions, which I talk about in Ottocento number 6. So the very first thing you need to do is look at these denominators and quickly figure out what the least common denominator or least common multiple is. So I'm looking at all those denominators, and I see 3, 6, 4, and 2. So I'm going to do LCM 3, 6, 4, 2. And the LCM is 12. So I would now go to my scratch paper and multiply that entire equation by 12, and the fractions should go away. So you see this function, it's like maybe once in a blue moon. You should be able to figure out the least common multiple just using your number sense. But if you can't, or if you just get nervous on test day, you have something to fall back on to help you get these questions right. I go over all this in Ottocento number 6. Definitely go check that out if you haven't already. Part 19, slider interface. Okay, everyone, so as you can see, I I typed in like a linear quadratic system, and we're going to try to find when this linear quadratic system has one solution using the slider that I made for the constant k. So first I'm just kind of just drag this around a little, and I'm kind of noticing, I'm like, it seems like it's going to graze it like somewhere right around here, somewhere between 0 and 5. So we kind of covered this in the slider video, but just to kind of drive home the whole idea of typing quickly. So let's say I want to change the range from 0 to 5, and let's say I suspect the answer is a whole number. So I'm going to click on this -10, and I'm going to put the smaller number first, the smaller bound, 0, and then you can use the tab key just like with everything else we've been doing. Tab 5, and then I'm going to see if the answer is a whole number. Let's make it 1. And then I'm going to click away. And now if I move this around, it'll move just in increments of 1. And I'm looking at it, and it seems like 3 is pretty certainly the answer. It is touching it at one point there. However, let's say we weren't sure. Well, then I could narrow the bounds even more, but actually I think my bounds are pretty good. But I could make this step something else. Let's say like 0.5 or 0.1, something more precise that will maybe get me closer to the answer. Anyway, I digress. The answer to this question is k equals 3. Part 20, putting it all together. Okay, we're just going to do a quick example that kind of sums up a bunch of the things we talked about today. So let's say I have the quadratic function f of x equals 1/2 x plus 5 squared minus 8. And I'm going to translate that using g of x, make a translated function, g of x equals f of x plus 6 minus 9. And I only care about the translated function. I'm going to zoom out a little bit using the scroll wheel. And I only care about the translated function, so I'm going to unhighlight the red. Now I'm going to do another set of functions and carry out a translation. So h of x, but before I do that, I'm going to look at the vertex. I'm going to plot the axis of symmetry just to make my picture a little nicer. So it's at -11, so x equals -11. And I'm going to hold left click on here, make it dash to make a nice axis of symmetry. That looks really good. Okay, so now I'm going to do another function, h of x equals square root of x, sqrt x. And we're going to do a function translation on that as well. How about I do j of x equals h of x plus 17 minus 17. And we want to find the smaller x value that satisfies the solution, that satisfies the system of equations formed by these two translated functions, g and j. So I'm going to get rid of h. I'm just going to unhighlight him. And maybe I'll change the color of j as well. Okay, that looks good. I'm going to pan a little bit with the left mouse button, get a nicer picture, maybe zoom in a little bit. Then I'm going to double click on the smaller x value, which is -13. So that's my answer. And how about just for the heck of it, I'll plot that point. How about we call it S for solution? -13, -15. I'm going to label it as S. And I'm going to come in here and I'm going to change the color to something that's not there. So how about red? And then I'm going to turn the drag off so I don't accidentally drag the point around. And that looks really good. So I'll jump to my scratch paper, write down my answer of negative 13, and then before I move on to the next question, I am always going to click the gear and clear my graph by clicking delete all. Okay, that completes the lesson. Please like and subscribe for more digital SAT math content. If you're interested in my tutoring services, the link to my website will be in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.